pin. I have no idea what you're talking about. I'm just working on my C++ project. You're talking about image to mock-up generation? No. I would say it's called definition of the function. Public. Constructors private as well. Hey Ninja. Yeah, I guess that maybe something like this. What? tough. Man, I lived a nightmare today. Still not over it. Still reliving it. It's like, yeah, like it was a nightmare, but it was real. Basically, now you want to know, of course. I had some run-in with my doctor, or run-in. Yeah, I've kind of lost faith in him, and so today I went for a talk with him, and with the intent to restore, our mutual trust, so I just can continue with him. And exactly what I didn't want, that's just what it started with. I came in there and he was like, I had it with you. You don't go away, find another doctor. Holy shit. I think I'm gonna have a really bad dream about it. But yeah, anyway, I stayed and I tried to talk it out, and that succeeded, I think. So everything is okay now, and he's still my doctor. But the way it started was like the worst situation that I could think. Exactly what I not wanted. Oh man, I'm really shocked by it, the whole experience. Definition, differentiate symbol. It's gonna take me a few weeks, I think, to get over it. And even then, even though at the end I gave him a hug, you know, I said, I think you're a wonderful doctor, and my faith is completely restored. I gave him a hug and everything, but it's still the whole experience of that moment is just really nightmarish. So yeah, I take a quote here, and we would just then, you know, whatever name it had, and then with an added quote, just send it. Differentiation, or that's the correct word. De afgeleide in Dutch. I'm just gonna ask ChatGPT or Gemini. Derivative. Okay. Yeah. So we're taking the quote is to it, or it's marked as the derivative of that function with that name. And the definition of the derivative is then, of course, the derivative of the definition again. Maybe I should rename this to derivatives. Sounds better, doesn't it? Man, it's more files than something else. Maybe we should just do it with SED. SED inline, very little big, dangerous, I mean. Execute, substitute, differentiate with derivative globally. Star. No, it's renamed to derivative. Okay, so it's test function as in I'm adding function. New headers go to at the top. Don't ask why. No, there's a reason for it. That way you keep a little bit track on if that header includes all the header that it needs, instead of relying on all the headers that you already included. Then I'm going to make a function with the name f and the definition x plus y. guess I'll just print it. It should just print F. Wait, I already have an F. Let's give it a little bit longer name. Function. Let's even use 2 characters here as well. Definitely not enough headers there. String, okay, clearly you also need expression. At which point, I don't know, expression. Just copy all the headers from a symbol. Anyways. Oops. Oh, just constant. Gotta be effing kidding me. What is that? Why does the symbol only include constant? Does not make any sense, I think. Hash. Precedence, I think, needed. Maggie. Used undeclared identifier value. Well, I know exactly what that is. Definition to be passed to the constructor of function. Instantiation undefined template hash function. hash dot h add function to the long list, and then add in some random number. To be used. Really? Insert random number. Go. Copy. Zip. Redefinition of hash log. Function. No matching constructor initialization of symbol. Really? Must be blind or lazy, probably both. No matching constructor initialization of function again. Well, now it's function instead of symbol. But why does name definition not work? Because it just doesn't work. I only have that. Stupid, ridiculous, of course. What's this? Standard string const reference name underscore name. What do you have now? Now we have missing function. Function txx missing. Forgot to compile it and link it. No sources. It doesn't even exist. Function.txx. Okay, something else is wrong. what probably is wrong is that I defined something that should be defined in function.cxx, but I didn't. That something being equals, right? That's basically the only thing. Why would I define that not inline here? Let's do it inline. Who cares? It's not going to be inlined anyway because it's a Wordle function. So yeah, steal it from some other non-template thingy. Symbol is so close to this function. To it's only equal when it is actually another function. And when that function, apart from existing, has the same name. Yeah, I could do that. I could also test if the definition is the same, but I include the definition in the hash. Maybe we should not do that. We should have a unique name, and if the name is the same, then it's just the same function. It could lead to certain problems. Otherwise I have to test the definition as well. You don't want to have a function with the same name and a different definition, right? Not really, but. No, I'm adding it. The name is the same, and no, it's not really correct. I think I should do something like add an assert, really. So if it is equal, then it must, aka it's not equal, or something. If it is equal, then it should also have an equal argument for definition. Definition underscore does not exist in other. No, It seems to be implemented. Let's see what happens. So it just prints fn, yay, and that is then x plus y. Let's make an accessor. Basically, it is an accessor. Shall we put the accessors? No clue. Let's put it at the bottom. Expression const reference definition const return definition. No, and I can print an evaluation, of course. Which will text that along here. Oops. Then I have to cast it. I would have to cast it to a function. It doesn't make it a function the moment I define it. So now the function fn, which has a definition x plus y, evaluates to 55, just like here. And of course I can take the derivative of that as well. So let's say we do test derivative. Is derivative of fn relative to x. Oh, let's make it x squared then. So the derivative is printed as fn apostrophe. Pretty cool. With this 2x, let's just evaluate it because printing it, I'll have to cast it again and blah blah blah. I can't do that. Okay, let's just print it the way it is, like. Say fnd is the derivative. That it must be a function then, doesn't it? Otherwise I can not print the definition. Yes, it is a function. derivative of fn. It's the derivative with respect, I think that is the word. Of relative, what is it? Is another function. So the derivative of fn apostrophe is 2x and evaluates to 2 times 13 because x is 13. Works like a charm. Yep, I think now I'm ready to incorporate everything into existing code as in let's link with I don't want to rename this actually. I don't rename it. I want to rename I want to eradicate symbolic. Is the old one. No more symbolic, and then rename that to symbolic. So that symbolic 2 does not exist anymore. Which means that we have to git remove. I'll have a closer look before I do that. I don't really want to throw everything away. It's still has been a lot of work. It's nice that to have something compile time. Maybe we should make it its own. Hey, empty codes, how are you? Okay, wait. I'm going to make a copy of it. What do you mean, how are you stream? I am not a stream. Ah, okay. I get it. Let's do an SCD again. Oh, I should have done that for this, for every file, including this and this. Just do that manually then. No idea why I'm doing this one by one. I don't know. Right. Suppose I change all of it. Or not. Yeah, okay. Well, yeah, well, okay. No. Go into symbolic. Git move. Eradicate. Errors. But what kind of errors? File not found. Symbolic.h. Confusing. There is no symbolic.h. But no, of course. Oh, I'm completing it again. Yeah, maybe you should add it in, like, it's basically a header that includes all other headers that are required. Let's say we include product, then I do get binary operator, which means that you get, oh no, forget it, I didn't do this. See, exiting, exit text, Pragma wants include product.h, which includes binary operator, which includes constant and symbol. I also need to include function.h, which, by the way, includes expression has and precedence only. So we are still missing power.h, which includes product. No, this is .cxx. Binary operator. Did I already look at that one? Yeah. Okay, and then we need to include some. And then I should have everything. But some already includes products. That was a known. Get that one. Close. Compile bitch. Damn it. Doesn't listen. Use of undeclared identifier and make symbol. Yeah, it's not really how it works anymore. Oh my god, no, I have to change this. Oh, I have to change all this. Okay. We can do this, we can do it. The cons expression has to go. Can the static stay? Do I want the statics to stay? They might as well stay, but it's very, very dubious. Let's just let's replace all the autos with expression cons reference. Make symbol. Or maybe I should call this alpha. That's what I used it. We called it before, but yeah, no. So the name registration is no longer required. I just give it a name above. And that these as well. Q1 and N1 are constant, do not depend. Okay, so they are assigned here. Oh, there are actually functions. Thus, right? No? No, there are symbols. Yep, they're definitely symbols. I just assign them here. These things are functions. So I need to substitute this whole thing where this is not a real expression. And the name I need to remember. Let's put that between stuffs. A to Z, A to Z, 0 to 9 in underscores. Static function, const reference, the const reference name is something like that, and I need the cut. This also must gone. Yeah, or not, but still. And then we have to do the constants here. A lot of constants, 2, so maybe a half, 2.5. Let's just make those also static. Constant const reference, 2 constants realize 2, and I have a half. Substitute constants 2 with 2, and then again using a half for 1 comma that thing. Let's just put everything on one line so I can edit it. Bulk edit it, I mean. I think that should work. Data memory machine initialize out of line. Ugh. Critical mode is static. I'm not convinced that a static makes very much sense, except, well, we think I calculate two quadratic energies, then yeah, they have different values, but it's about it. The hash is the same, the definition, almost everything is the same except the symbol values. No, whatever. Let's remove the static for now. Now what? No matching function of equal to sign. Oh, I forgot to include that. VI block.h sign in so on. Include sign cosine a ton and log. No vowel conversion from cons expression to cons function. Oh right, that is true. Because I need to realize, obviously, I don't even have to give it a name. Forgot to give those things a names. Oh wait. That one too. Substitute. Yeah, the name. A through Z, 0 to 9 underscore any number. That blob followed by equal sign. And then no space, and then the definition, which is basically everything except until the semicolon. And I want to replace that with, well, obviously the name again. Equals function realize quote name quote comma the definition. Yeah, maybe I should not have included the underscore. Removed underscore. Underscore. Does not compile. Again, object with abstract class expression. Is square not working? Thought I made square working. It's using the wrong square. So square. Oop, 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 oop. Isn't it this one that should be used? It's the one that should be used. Why is it not used then? Why is this not used? Okay, so it doesn't like it that it is a function. Okay, let's do this a more clean way. Remove the namespace. It's just the util square is not working, period. So let's just do the substitute utils util square with well, nothing. Just a square. I think that's because it's not marked as a symbol. These are all symbols. Test is still using it. Test suit uses utils square. Well, that only here, and I can just remove that here. So Undeclared identify evaluate. Contradict energy. Evaluate arc length. Okay, that's a difference indeed. It should be now arc length. Dot evaluate. Compiles. Amazing, you know, amazing. Just the correct value. Just bam, it works. Just works. Pretty amazing. Yep. And now we can do something else. What we get never done before. I can enable this one. That would blow up my PC because the compiler would use too much memory. So before we could not compile this, right? Because just, yeah, gigabytes and gigabytes of memory were needed to compile it. Done. What do you mean difficult to compile? Very simple. Very simple. So I've been printing this. Arc length is correct energy, and I'm printing the arc length. And then we have talk about energies here. Quadratic from. This is probably something else, isn't it? It's the square of the arc length. Yeah. Quadratic bending energy, I don't have at all, of course. There's this one. Okay. So in order to test if it really works, I should get the same value as well for that. How to do that? It's already done here. No, what? Yeah. So I can do. the feeling that they should be included here. So quadratic energy has a quadratic stretching energy function. No, just stretching energy. And that's our new formula. Of course, that I mean, that's the thing that didn't compile before. It's a square of this one. So it does work, but hey, might as well actually test it. Too few arguments to function call. Expected to have 0. Stretching energy needs 2. What? Oh, I need to pass the 2 angles to it. Just like I did here. I think I forgot something. Switch profile to YouTube. Oopsies, super small font. Yeah, turn out compiles and I can run this test again. Yep, same value. Oh, that is awesome. Now, of course, what I want to know most is what the derivative looks like. I'm not sure if I can even print it, but hey. The derivative of that square, that's like, wow, awesome, if I actually can print it. Let's see if that happens or is possible at all. Let's say I want to print, it's gonna be something easy, I'm afraid. I want to get, let me see, the bending and this. This is just giving a double, right? I need a function. Going to add a function here, print derivative to quadratic energy. Then where is that defined? Don't tell me it is not defined here. I think I removed symbolic, right? No, it's still there, so I just have to remove this. What? Yeah, exactly that. Void. Oh, it's such an idiot. I just have to call it. Uh-oh. Oh, right. What? Okay. Yeah, so this is treated as a symbol, even though it's a function. Symbols are not less than constants. Worse, it should never. Well, maybe make product deals with it that it is a one. Might actually deal with it. No, it doesn't. It deals with argument one being one. But this must hold before that. So it should never have been called with a symbol here and a constant there. So why is argument 2 a constant? Multiply. Yeah, that, I mean, yeah. That could be less than this if it is 1. But that's strange. Maybe it's not that strange. So argument 1 is less than argument 2. And then I think that therefore the multiply is larger than argument 1 as well, which is just not true. Apparently. So here I have argument 2 is symbol-ish. I think these things are sorted by name, so that's very, very, very random. Yeah. ZPA is less than ZPV because A is less than V in the lexicography. And then what is this? Indeed. It's the inverse of that function. So then we multiply that and you get 1. Hmm. Should use multiply again. Yeah. I guess I should. So yeah, just printing this. The code isn't really telling me that it is the partial derivative relative to that though. Maybe I should have renamed the name to this instead. So I would rather see the definition of it than just the name. The name of the derivative is never very interesting. Yeah, let's change it to this. Just the full blown thing, right? I need my round D back again. I thought I have it here. That cap. I need the name of the symbol. For which I do not have a accessor yet. So let's add that one. I now know where to add my accessors here. Put it somewhere. And then I want to print the definition after it as well. Oh, wait a minute, it's just the name. Where am I printing the thing? So the derivative of the stretching energy relative to V0 QA has the value 2 times the arc length times the derivative of the arc length, the derivative of the arc length to V0 QA, which of course is because the stretching energy is just the square of the arc length. So you get this and then times the derivative of that. Well, that is 100% correct, but suppose I want to print the whole thing recursively. So now I want to print arc length in full. And the derivative of that in full. That is involved. Just need a custom IO manipulator to switch from printing the normal name to printing it in depth. Can even add a maximum depth, so you can make the depth larger and larger, or something like that. I think I need to eat first, because it's getting later and later and later and later and later and later and later. Let me try one thing though. Let me try printing the value of the derivative. And then see if I can get that to 0. So aka a minimum. And then I go eat, okay? Nobody knows this. Just somewhere. Right, so the value is, well, I want to show you what it is, but this is the value, 169. And that is the derivative relative to this angle here, the green thing. So I change this, then it gets larger, 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 larger. Well, derivative gets larger. Okay, I'll make it smaller instead. So clearly it's going to 0 at the moment that the angle is 0. It is correct because, well, the length and thus the square of the length gets larger and larger if I make this angle larger. And the minimum is where the angle is 0. What I don't like, however, if I make the angle negative, then it doesn't exist anymore. Oh wait, actually it's not printing anything now. It's not printing it. Okay, that's cool. Yeah, so I'll do that here. The value is indeed minimal and the angle is 0. Try to get it, well, it's pretty minimal here. Okay. Less than 1. On the other hand, if I make it larger and larger and larger, this goes to infinity. Say that, oh, this must be very big. Yep, it is very big. And if I go past that point, past infinity, then it is not printed anymore because it doesn't exist. Yeah, it works. Completely works. I change this angle to there. Unfortunately, the minimum is always going to be at 0. Just because, yeah, this is a straight line. It doesn't get any smaller than that. I'll do this again. 10, 8, 7, 5, 3, 1, 0 0.2, 0.33. Progressively doesn't want to get smaller. Well, anyway, that's like a straight line. So I have to combine that with the bending energy before we get to see anything interesting whatsoever at all. It seems to work. Seems to work. Well, it's interesting to see if the derivative changes if I change the other angle. So I'm changing this angle here. Does then the derivative relative to this angle change? I suppose it does. Yeah. Oh yeah. Of course it does. Can also bring this to infinity. And also to 0, in which case it's again very much 0. So now I change this angle so that it's just a straight line. So it is still, this is still the angle. It just goes in that direction and then immediately bends as sharp as possible in order to arrive here at that angle. But yeah, the result is still a straight line, so that's pretty cool. See? It works. Great. Yeah. So what I learned after several months of coding is that the shortest path between 2 points is a straight line. But we're not done yet, of course. I'm going to make dinner.